Hello everyone. Back to you again, dear MoroccoAI audience, in this third day of the conference. This is the last day of the conference, and I hope you are enjoying what we are doing at this conference. So, for our first speaker today, it is our great pleasure to welcome a great researcher working here in Morocco, Professor Ali Idri, who is going to speak about a very important subject related to data processing in medical knowledge discovery. So thank you, Professor, for accepting our invitation to be with us at this first Morocco AI conference. So maybe now let me introduce Professor Ali Idri. He is a full professor at NCS, l'École nationale supérieure d'informatique et d'analyse des systèmes. He received his PhD in cognitive and computer science from the University of Quebec in Montreal. It is also important to know that Professor Ali Idri is ranked among the top 2% researchers in the world across all scientific fields. He has been awarded the best Moroccan researcher in computer science for the years 2016 and 2020. So now I will say, please welcome everyone, Professor Ali Idri. Professor, the floor is yours.
Okay, so thank you very much for the introduction. Thank you very much for inviting me to this conference. I am pleased today to share with you one research line that we investigated for more than 1 decade in our research group here in NCS University Mohammed V, which is data preprocessing in medical knowledge discovery. So as you know, knowledge discovery consists on discovering knowledge from data, and it becomes one of the most fruitful field application of knowledge discovery in many domains, in particular in critical domains such as medical, which will be the subject of this presentation. So this is the outline of my presentation. The first motivation and objective why data preprocessing is very important in the knowledge data discovery. Second, an overview, what are the data preprocessing tasks that we can face during the data preprocessing step, and also what are the techniques that can be used for each task. Second and third, I will present an overview of the literature that we have done. So the first one is on the use of data preprocessing in general in all the medical subfield, for example, in cardiology, in oncology, and other. And the fourth point will be dedicated for heart disease classification. And why heart disease classification? Because in our first review, we found that the subfield that was the subject of data processing, most frequently subject of data processing, was heart disease. And finally, I will conclude by summarizing some contribution that we have done in applying some data preprocessing techniques in different medical subfields, in particular in heart disease and in breast cancer. Okay, so as you know, knowledge data discovery can be consist of 3 main steps. The first one is data preprocessing, which is the main subject of this my talk today, and in which the objective is to clean the data in order that the data be after used for knowledge extraction. And as you know, garbage in, garbage out. So if you don't have a good quality of data, everything that will happen after modeling and the knowledge that will be extracted from the modeling step will not be useful for the user. The second step is the modeling, which is the most famous, let me say, the step of the knowledge data discovery, in which we apply different data mining technique for classification, for example, for regression, for clustering, and for association. And the last step should be when we extract knowledge from data by using some modeling technique. This knowledge should be verified. First, it should be verified by data scientists by using, in general, testing data. And thereafter, it should be validated by different stakeholders that will use data in their real life. Okay, so this is show the distribution of the importance that recognized in the literature for each step of the KDD process. You can see here that the data preparation is the step that is the most important than the modeling step, than the evaluation, and the deployment of results. So most of the studies that have done and that look for what is the importance for each step in the KDD process, they found that around 30 to 70% of effort and time in the KDD process was devoted to the data preprocessing, and only data mining modeling step took only between 10 to 25% of effort and time of the KDD process. This is why data preprocessing is very important and can take a lot of time of the KDD process. So in medicine is the same. Like in critical domain, data preprocessing is very important because in general you will have some noises in the data. Noises can be in the form of unbalanced data, can be in the form the presence of outlier, the presence of incorrect data, future selection, future reduction, and so on. So all these kind of pieces that we can find in the data can be qualified as noises that should be corrected, that we should deal with in order to have high quality data, and thereafter we can go ahead with the other step, data mining, modeling, and knowledge verification and validation. Okay, so what are the tasks that when now in preprocessing? We can categorize them in 5. The first one is data integration, data cleaning, data reduction, data transformation, and data balancing. And for sure, for each task, you have several subtasks to carry out. And for each subtask, you have several techniques that are dedicated to solve the problem of this that you are facing in the preparation. So this is a figure that can explain in details from the data. When you have the data, maybe you can have different sources. So the first task is the data integration. You should carry out some techniques in order to obtain from these different sources one source for the data, which will be used after for data cleaning. And in data cleaning, you can have different subtasks. You can have outlier detection. This is a form of noise that we can find in the data. Missing data also is a form of noise. Inconsistent data also, and incorrect data. So this is the subtask that we can carry out within the task data cleaning. After that, you will have a clean data, which means that you have avoided all these challenges. And after, you can carry out data reduction. It consists on dimensionality reduction. As you know, is very important that you provide a solution with a low dimensionality so the user can understand well the model. So here you have, in general, 2 subtasks that we can carry out in order to reduce the dimensionality: future selection or future extraction, and also discretization. Even some researcher classify discretization not as a data reduction pieces, but as a transformation. And after that, when you reduce the data, even you use future extraction or future selection, you can use maybe transformation. And the main form of transformation is normalization, which means that you have a set of future, and for each future you have a range of values. And the idea is to keep or to transform all the variables that they have the same range. So you cannot bias your model, since there are some data mining techniques, like, for example, canary snipers, like neural network, that are very sensitive to the range of the variable. So if you keep your variable, some of them have high range and some of them have low range, they can impact negatively the modeling. I mean the meaning, not only the accuracy, but the meaning and the usefulness of the model. After that, you have the problem of data balancing, which is specific to classification. We don't find this problem in regression, in clustering, or in association. It's just for classification, which means that you have the concept of majority class and the concept of minority class. And this can be solved by different technique, like, for example, oversampling or undersampling, random, or using other more sophisticated technique, or you can use sensitive cost learning. I will detail some of this elements in the next slide. After that, you have the data mining. So at this stage, you have all the challenges of data preprocessing has been solved. So now you can start to model. You can start to extract the information, and the information can be a form of rules, can be a form of trees, any form that can have considered as an abstraction of the reality. And thereafter, you provide the information for the final user, and the information become a knowledge. Knowledge means that the information has been used in the real life, and it was useful for the different for the final user. So now is some detail in depth about each step, data integration. So as I said, data integration is to collect data from multiple, maybe heterogeneous sources, and fuse them into a coherent and unified data set. And here you have several challenges to solve, checking for the duplicate of tuples, the identification and unification of variables. But let me say that this step data integration is more, we can consider it is more computer science than data scientist. So you can solve this problem by manual data integration. You can use some application that you developed and is dedicated for this kind of data integration, and so on. So this is more, let me say, computer science than data science. Okay, so for data cleaning, which is specific for data scientists, so cleaning means that you should avoid clean the noise. And as I said, noise can be missing data. So here you should look for how to correct this. And I will explain that there are at least three strategies: dilation, toleration, and imputation. Noise, when it is defined as incorrect data, so you should correct this data, or you should remove the line or the instance with incorrect data. How to solve the problem of outlier also is a kind of noise that can appear in the data, and data with the same meaning but different form. So okay, so here you have for missing values. So there are three strategies that you can adopt. In general, dilation, which consists on removing the data that contain missing value. This is most frequently used in case when you have low percentages of missing value. For example, you have only in your data set 5% of the data contain missing value. I think in my point of view, the best way to deal with this situation is to delete all the instances that contain the missing value. You have toleration. Tolerations mean that you keep the instance, but you put for each missing value you put a specific value, which means null. That means that this is nothing there, and the algorithm, or in the step of modeling, the algorithm will not consider this value as a value. It's just something. It doesn't mean anything. So this is what we mean. You keep the line and you put a null value, which means nothing in this case. And the imputation, which is the most frequently used, which means to fill in the missing value by using some machine learning technique or some statistical imputation technique, like, for example, the mean imputation, the mode imputation, which are statistical imputation technique, or you can use other machine learning technique like k-nearest neighbors, most famous one, super vector machine if you are in classification, if you are imputing categorical data, or SVR if you are imputing numerical data. For correcting data that are incorrect, here also we can use different technique. We can have prediction, like in the case of missing values. You can consider that the data was missed, and you can apply any algorithm for imputation. Or you can have what we call the binning, which means that you have the column in which you have the incorrect value. You sorted the value from by the ascending order, and you form what we call the bin, which have the same size. And after that, you can substitute the values by mean of the bin, or you can substitute the value by the smoothing by the bin boundaries. I mean, the value that is near to the boundary that is near to the value in the bin. For outlier, we can make detection. First, we should detect what are the outlier. Outlier are the values that are out the normal range that you have in the column. So one technique to detect first the outlier in a column is to use clustering technique. For example, here, all the points that you see that are not within a cluster are suspect to be outlier. And how to deal, this is for detection. Now, how to deal with outlier? One of the techniques, there are several techniques, but one of them is discretization. In case when you have numerical values, when you have numerical values, you can apply discretization, which means that you make transformation from numerical value to categorical one, and at this time you can mitigate the effect of outlier by this transformation. Inconsistencies data means same data with different forms. So here is very simple. We can use some data auditing tools for the date, for the spelling, and for also some data scribing tools that are available, and you can correct the format, and all the data will be, the same data will be with the same form. For data reduction, you have feature selection, which means to reduce the number of original features. You select only the feature, a subset of feature that is relevant for the tasks, classification, regression, association, or clustering. Feature extraction means that you have a set of features, and you calculate new features from them. And for sure, the new number of new features will be lower than the number of original features. And also you have discretization. As I say, some researchers did not include discretization as data reduction. They include it as kind of transformation. I keep it for me here as a data reduction technique, but it can be classified by other researchers in the other task. Okay, so for feature selection, you have different type tree families. You have filters, which evaluate the characteristic and the importance of the feature depending on the target variable without including the learner. The wrapper is evaluate the importance of the feature, but with including the learner. So we select at the end the features, the subset of features that led the learner to be to outperform well. And you have the embedded technique, which is a specific kind of modelization. In this case, you have the classifier. In the same time, it is the classifier and it is the feature selector. An example, a well-known example, is decision tree. You know, decision tree, when you make modelization with the decision tree, the first step is to look for what the variable that will be in the root. And this is the main, according to the tree, is is the main significant or the main relevant feature for the task. And then you have the features for the second level and so on. And the feature that did not appear in the tree, that means that these features are not relevant. So descent tree, for example, is an embedded technique. They carry out the classification, and at the same time, they carry out the feature selection. And each feature selection technique, even filter or wrapper or embedded, can be univariate or multivariate. Univariate means that the filter or the wrapper provide a kind of ranking for each attribute, for each feature. It provides a kind of ranking from the most significant to the low significant. And at that time, you have the freedom to choose how many feature you want to consider. You can consider only 10%, the first 10%. You can consider only the 21st%, and so on. So they provide only a ranking of the future. While multivariate, they didn't provide a rank. They provide you the subsets. They make different subsets, and they evaluate the relevance of the subsets depending if they are filtered on the target variable or they are wrapper on the performance of the learner. And at the end, they propose for you, this is the subset of features that have conducted that is the best one for the learner in order to reach a high performance. So this is different point of view. Univariate is only a ranking of features. Multivariate, they provide you with the exact subsets, and at this time you should use it because this is the subset that has led to the most accurate performance. And this is some examples. You can see vector machine as univariates, and you can, most of them is, for example, for filter chi-square, which is the way now. Okay. So data reduction is, as I said, you have a set of features here, and you try to extract new one. For sure, we will reduce the dimensionality, and it's not like feature selection. You see feature selection, we keep the original feature, but we select only some of them. While in feature extraction, we transform all the features in a new features, like for example, principal component analysis. You have x1, x2, xm, and you make transformation to have the main components C1, C2, and with a dimensionality lower than the initial one. So this is different. Okay, for discretization from numerical to categorical values, so we have two kind of techniques, supervised. In this case, you have some empirical knowledge, you have some predefined classes, and you try to transform each numerical value in the predefined class. That empirical knowledge confirm that this value belongs to this empirical class. Otherwise, if you don't have empirical knowledge about a set of predefined classes, you can use unsupervised learning, and at this time you will define your cluster, and then you can after provide some labels for this cluster. Data transformation, the main famous subtask in data transformation is normalization, which try to transform different variable with different ranges in the same range, in general 0, 1, or -1, 1, in order to keep the variable have the same impact on the model. And data balancing, as I said, this is the minority and majority class, and the idea is to have classes with the same distribution. And here you have two kind of techniques. The well-known is sampling, means that you can add some instance for the minority class, or you can delete some instance of the majority class. You can do it by random oversampling. You can do it by random undersampling, or you can do it by smooth, which is one of the most well-known algorithm to carry out the sampling technique. And there are another approach which is, in my point of view, very interesting, is the cost-sensitive learning, which is, in machine learning in general, when you perform the learning, you perform the learning depending on the number of error. I mean, for example, for classification, in the number of misclassification cases. This is the normal learning algorithm. Cost-sensitive learning means that you are adapting the learning not depending on the number of error, but on the cost of error. And this is different than the first one, because this is not the number of error that is a matter for you, but the cost of this error, that is a matter for you. And this is a kind of solution that we can use for data balancing. Okay, so now I will move to the overview, the first one that we have done, in order to present for you what we found, what we have found in carrying out on the use of preprocessing technique in medical. So this is the question that we are trying to answer: publication year and venue for the studies that's focusing on data preprocessing technique in medical. What are the medical disciplines that are most frequently investigated by data processing technique? What are the preprocessing tasks that are mostly used in medicine? Type of research have been used, and the empirical method used. And this is the statistic. We have carried this in studies from 6 digital libraries: IEEE, ScienceDirect, Spring Link, DPLP, PubMed, and Google Scholar. And at the end, we have a pool of 126 papers that have investigated data preprocessing in medicine. And from this 126 paper, we try to answer the question that I presented in the last slide, the previous slide. Okay, so this is the distribution. So here you can see that the study has been done from 2000 to 2017. And as you can see here, the number of publications dealing with data preprocessing in medical is increasing. This means that it's become very important also in this field. Publication in journal becomes very interesting, and this is very important because it shows that there is a high maturity level within the community. And for the publication, here you find some journal that you can target, and well-known journal in medical informatics. Artificial intelligence in medicine, this is one of the very famous journal in which you can publish, and this is a very good point for any researcher. The computer in biology and medicine, and you can have also here the list of all journals and how many publications have been done in this journal. This is distribution about in what medical subfield data preprocessing was mostly investigated. So as you can see, the first one is cardiology with 35%. This is the most targeted by data preprocessing technique. You have endocrinology with 19%, and you have oncology with 16%. So this is why we focused after in the second review on cardiology, since it was the main domain in which data preprocessing was investigated. And this is the preprocessing task, and you can see that data reduction is the most frequently investigated with 55. And this is in medicine, this is very important because in medicine, features mean clinical test. And clinical test is very important for saving the time and saving the cost. So if you can reach a decision for a diagnostic or for a treatment by using only a small number of features, so it will be good for the doctor and also for the patient, because you will save time, and you will save a cost, because all the data are a kind of clinical test. And for the second 29%, you have data cleaning, the missing values, outlier, and so on. Okay, for research type can be classified in three types. Evaluation research means that the study has done an evaluation of a new method or existing method. Solution proposal means that the study have done a solution, have proposed a new solution or improvement of an existing solution, and maybe has done or not has done the evaluation. So here you can see that 77% of studies are evaluation research, which means that within the community we are trying to evaluate, compare existing and maybe new techniques in order to, for each context, because it depends on the context, for each context, which technique will be, which data preprocessing technique will be the most suitable.
Excuse me, Professor. I don't know if you can just please present 2 further slides to not be over time.
Okay.
Thank you very much.
Okay, so I will skip to the for heart disease, just to show you the finding regarding, for example, here you have the preprocessing subtask you have for the cardiology. As I said, data reduction is the most frequently used, and within data reduction you have feature selection is the most, the one with the green, and feature extraction is the second. And it can be explained by the fact that in general we prefer, in my point of view, I prefer used feature selection, since feature selection you keep only a subset of the feature, so you don't lose the information. While when you use feature extraction, you transform your data, your variable to a new ones, and at this time you completely lose the information. So this is why, in general, for critical domain, like for example in medical, they prefer in general use feature selection than feature extraction. And for feature selection, filters chi-square is the most well known with 70%. For discretization, you have supervised discretization. For imputation, you have the k-nearest neighbor with 12%. And for the normalization, you have the max-mean normalization, which is the most frequently used. For the impact, this is very important, how the preprocessing impact the performance of classification, in order to decide if preprocessed data will improve the performance or not. So here you have a table, it shows that, for example, for feature selection, you have 125 evaluation that has been done, and in 66% with or without feature selection is the same. 30% is better to use feature selection, and 5% are against the use of feature selection. For example, for feature extraction, is 93% is the same, which means that there is no advantages of using feature extraction. I mean, from the study that we have summarized in this review. Okay, so I will move to the contribution that we have done. But we have done a contribution in feature selection, and we chose in the first time to start with filters. Why filters? Because filters are easy to implement, are not dependent on the learner, so we can go faster, and filters also are the most frequently used. And we investigate in the first 3 filters, the relief, linear regression, and info gain, and are one of the most frequently used depending on our literature review. And we investigate them with 4 classifiers. And the objective here is to look what is the percentages. As I said before, filter make a kind of ranking, and you should fix how many variables you choose for the modeling step. You can choose 10%, 20%, 40%, or 50%. So you make this range, and you answered the question, and most time it was 40 or 50% that led the learner to be more accurate. Okay, after that, there is another contribution in terms of comparing univariate and multivariate, and we investigate 6 univariate with 2 multivariate, and we carry out the same experiment. But in this case, we keep what we found in the last in our previous research. We keep only percentages in terms of 40 and 50%, and we have 4 questions that we try to answer. We included also optimization technique for the grid search for the classifier in order to study if there is any combination of optimization technique, feature selection, and classifier that can outperform all the other in all the contexts. And the empirical has been done in 5 data sets.
Just a quick reminder, Professor, to not be over time, please.
Okay, 1 minute, 2 minutes is okay
yes,
for you?
Okay. 2 minutes, yes,
okay,
please.
Okay, thank you. Okay, thank you. After we have the heterogeneous, this is a new line that we have in our research group, is to use ensemble. You know, there is a main confirmation in machine learning, that is, no learner can perform better than the other in all contexts. This is why in the research community in machine learning, they develop what they call ensembles, which mean that you can use different technique in order to have the output. So this concept ensemble has been used in classification, has been used also in regression. So here we try to use it, but for feature selection. So we have different feature selection, and we investigate here in this study the heterogeneous, which means that the ensemble is composed of different features. And we investigate also not only heterogeneous ensemble, but homogeneous ensemble, which means that the ensemble is composed of the same learner, but with different variables. And we do that for feature selection, and we do it also for missing values, because we have done also here some studies in cardiovascular, in breast cancer. We did the same comparison of different imputation technique, dilation, toleration, and kinase imputation. And in general, kinase imputation was the most have the most positive impact on the classification. We have done also homogeneous ensemble for kinase, and we have done also heterogeneous ensemble. The idea is to look if the concept of ensemble, that is in general used in classification, in data mining modeling, if this concept can also be used in preprocessing and can improve the data preparation, in order that when you move to the data mining step, you will have a model that outperform better than if you use only single technique in data preparation. Okay, I think this ends my presentation. Thank you very much. And if you have any question, you are welcome. Thank you very much.
Thank you. Thank you so much, Professor, for your very important and interesting presentation. Thank you again, Professor, for your presence with us today in this first edition of MoroccoAI conference. And we hope we will meet you again very soon. Thank you.
Thank you very much, and hope to meet you in the next edition 2022.
Inshallah. Thank you again.
Thank you very much. Bye-bye.
Bye-bye.